Okey, kita sambung lagi. Dah habis dah principle of AAS. Now we look at the film AAS. Ya. So under film AAS, kita akan tengok sample atomization. Dah tengok dah. Now we look at the flame atomizer and property of flame. Tengok mana dulu, sama ada property of flame ataupun flame atomizer dulu. Okay, this is types of flame under property of flame. So yang ini kamu tengok dia punya fuel, oxidant and temperature that is produced with the combination of fuel and oxidant. Yeah. So acetylene and nitrous oxide flame is the best for refractory element, because acetylene combined with nitrous oxide, acetylene dengan nitrous oxide ni dia boleh produce quite high temperature. Okay. What is refractory element? Refractory element is the element that form a stable compound, which are not completely atomized at the temperature of the flame or graphite furnace. Bila dia produce refractory element ni memang orang panggil kuat stubborn juga, nak degradekan dia balik atau nak dissociatekan dia balik into atoms. So that's why we need a high temperature for this process. And the selection of flame types depend on the volatilization temperature of the atoms of interest. Kita kena tahu sampel kita tu dia boleh vaporize, volatilize at what temperature. Kalau yang tinggi tu kena cari combination yang produce high temperature. Kalau yang biasa-biasa tu tak kisah. Commonly used adalah acetylene dengan air. Okay, so this one commonly used acetylene as a fuel and air as an oxidant. Okay. So flame are only stable at certain flow rates. So at flow rates less than the maximum burning velocity, the flame propagates into the burner body and cause flashback. And in some cases, it will cause explosion. So that's why we need to adjust the flow rate betul-betul. Tak boleh terlalu rendah, dan tinggi pun kita tengok apa akan jadi. When the flow rate is increased, the flame start to rise above the burner body. Ini kalau kamu buka, siapa biasa masak kan, kalau buka besar sangat gas tu, api tu akan naik ke atas sikit kan, macam ada gap between the burner body dengan api tu. So it will cause our analysis less accurate, because remember, flame must be aligned appropriately with the radiation source. So that's why benda ni tak boleh lah, kena optimum flow rate. Best flame are obtained when the flow rate of the gas is equal to the maximum burning velocity. At this equal ratio, the flame is most stable. Biasanya kalau kita run instrument tu, kita tak perlu dah set yang ni. Biasa the supplier dia akan set, dia akan ajar kita, tak perlu tukar sangat the flow rates of the fuel, ataupun oxidant. At higher ratio, flame will reach point where they will no longer form and blow off the burner. Kalau terlalu tinggi sangat, flame tu tak ada pun, dia terpadam terus. So that's why flow rate is very important. Parameter need to be set to avoid all this happen. Okay, this is flame structure. This is quite important for you to know. The region of the flame, we have 3 regions. This is primary combustion zone. This is interzonal region. And the blue one yang paling luar ni is the secondary combustion zone. So, let's look at the definition of interzonal dengan secondary combustion zone. Interzonal region is the hottest part of the flame and best for atomic absorption. So, radiation kita mesti tengah-tengah ni, macam saya punya Macam saya punya cursor ni ya. Mesti dekat tengah-tengah. So that we will get the accurate measurement. Yeah, in the interzonal region. Yeah. Interzonal region is the hottest part. So normally atomization will be optimized in this region. Okay. And the radiation source must align in this region. Yeah. Okay. And the second one is the oxidation, the secondary combustion zone. Yeah. It is where the oxidation of atom occur. Yeah. When the atom form molecular oxide, it will disperse into the surrounding. Yeah? Oxidation of the atoms happen in the secondary combustion zone. So this part is not very important for us in under analysis, but you must know. Yeah? So that's why radiation source mesti melalui tengah-tengah api ni. Okay. And this is the temperature profile. Kalau kamu tengok pun, tengok yang paling panas adalah in the interzonal region. Ya, daripada 1008 sampai 1863 ni. Ya. This is for natural gas and air combination flame. Ya. Kalau kamu guna natural gas dengan air, so this is the punya temperature profile of the flame. Okay, flame absorption profile. Temperature of flame depends on the position from its tips. Ini tengoklah dia punya profile tadi. It is necessary to concentrate on one spot in a flame and adjust the height of the flame to get best signal. Macam saya dah mention banyak kali, radiation source mesti align properly to the height of the flame so that we get the interzonal region, not the secondary combustion zone ke, not dekat dekat awal-awal yang paling bawah tu kan, yang tu tak panas juga, dekat tempat fuel dengan oxidant mix tu. And each element has its own specific height above burner tips. Burner tips tu, so for example silver, it will oxidize slowly. So use higher distance from the tip so that the higher temperature are achieved to analyze the silver. Silver ni dia lambat untuk oxidize. So kita make sure radiation source tu align at a higher distance from tip daripada bawah tu. Interzonal region, tapi interzonal region tu pun lebar kan, tinggi kan. So kita adjust so that the radiation source higher sikit compared to the other metal daripada dia punya tip. Chromium, best result occur at lower height daripada dia punya tip. So kalau you analyze chromium, adjustkan dia bawah sikit. Kalau magnesium, increasing the height above tip will increase the signal due to the increased atomization at a higher temperature. However, at a higher distance, the oxide start to form, leading to decreased signal. Okay, this one, not very high, not very low. Okay, this is the signal versus height of silver, magnesium and chromium. So the optimum is terlalu tinggi pun tak, terlalu rendah pun tak. Around here lah maybe. Kalau tinggi sangat nanti takut dah masuk secondary combustion zone dah. Okay, so that one is the flame properties. Now we look at the flame atomizer. For flame atomizer, ada banyak benda, tapi we look at the nebulizer. We have a few types of nebulizer. This one you tak perlulah tahulah sikit contoh dia. Setakat ni tak pernah lagi lah keluar. So first we have A is the concentric nebulizer. This is concentric nebulizer. This is cross flow nebulizer. This is freighted disk nebulizer sebab dia ada disk ni. This is Babington nebulizer. Okay. Semua function dia adalah untuk form a mist of the liquid. Kamu tengok, this one is a mist lah. Droplet, water droplet tu. Okay. Method of sample introduction in atomic spectroscopy. So, this is the method and this is types of sample. Kalau kita ada solution, kita boleh guna pneumatic and ultrasonic nebulizer. Kalau kita ada solid, liquid or solution, kita boleh guna electrothermal vaporization. Ya. Tapi kita hanya guna, sorry. Ni banyak lagi, tak apa. Kita tengok je. Kalau solid powder atau solid metal, you boleh guna direct insertion. Direct insertion ni adalah dalam sorry, Allahumma salli Muhammad. Saya tak ingat nama dia. Sekejap ya. Electrothermal. Ya, electrothermal. Kita ada apa yang oven yang panas sangat tu. Saya tak ingat dah. Ya. Okay. Kemudian kalau conducting solid, you boleh guna spark or arc ablation ataupun glow discharge sputtering. Yeah. So this is the method of sample introduction in atomic spectroscopy. Lain-lain instrumen, lain method dia. Kalau instrumen yang kita ada ni adalah nebulization dengan electrothermal. Ya, dia tiga-tiga. Ada hydride generation juga. Hydride generation ni adalah untuk spesifik untuk mercury. Okay, the second one, yang first tadi nebulizer, the second one is burner. Burner, the function of burner is as an atomizer, convert sample into gas, phase, atom or elementary ion. Because burner ni adalah api. So, dia boleh convertkan sample kita jadi atom ataupun jadi elementary ion. There are two types of burner. We have turbulent flow burner and laminar flow burner. So this is turbulent flow burner. Nebulizer and burner are combined into a single unit. Dalam ni adalah nebulizer dan juga adalah burner. Sample solution is directly aspirate into the sample. They suck in masuk into the into this flame. All dissolution, atomization and excitation occur in the flame. And the sample is drawn up the capillary and nebulized. Sample flow rate is 1 to 3 ml per minute. Disuck in sample kita dalam rate 1 ke 3 ml per minute. So this is turbulent flow burner. The advantage of turbulent flow burner, it can introduce relatively large sample. So normally large sample will be a representative sample. But the disadvantage is dia punya path length quite short, relatively short path length of the flame, and it can cause a problem with clogging of the tip. Sebab dia punya bentuk tadi tu hujung dia ada tip kan, kadang-kadang dia boleh clog ataupun tersumbat. Burner noisy from electronic and auditory standpoint. Dia bising sikit. Kalau yang type ni dia bising sikit. Then we have laminar flow burner. This is turbulent flow. This is laminar flow. Okay. Tapi dia punya nebulizer tadi tu dekat sini saja. Okay. Sample is nebulized by the flow of oxygen past a capillary tip, resulting aerosol then mixed with fuel and flow past a series of spoiler. Ni baffle ni. Ni baffle kita yang ni. Kemudian dia akan masuk ke dalam burner head. And only the finest droplet reach the burner head. So laminar flow ni is better than yang first tadi. Okay, so yang inilah ni. So this is nebulizer oxidant. Ni sampel kita.